Okay, we're going to cover 2 sections really quick. Then we'll be done with chapter 3, move on to, I think, a little better stuff. Quickly, just remind us, what is slope? Rise over run. We all know what slope is. I know we do, but we'll just say it out loud a couple times. What's the variable that we always assign to slope? M. Okay, so for slope, it's because it's French. I can't remember why. I used to know, but it's a French word and it starts with an M, so it's M.
You don't know how to spell slope?
Maybe.
No.
Okay, so now let's come up with a couple other little bit, maybe more precise ways of saying slope. So if we had to come up with maybe a formula, what do you think?
y2 minus y1 over x2 minus x1.
Okay, we could say y sub 2 minus y sub 1 over x sub 2 minus x sub 1. That's fine. Now, something about this, though. I want to be real clear about this. Remember that when we, okay, let's do maybe one more way, and then I'm going to say something. What else? What is it? Yeah, sure. We could call this delta y over delta x, because delta just means changing. Okay, but there's a difference here between the delta y and the delta x we use for the distance formula. Remember that we said before, I want to make sure we get this because this is a source of confusion for people sometimes. Our distance formula, so this is slope. For distance, remember we got d equals the square root of delta x squared plus delta y squared, right? And so if we wanted to, for example, let's just take a pair of points and let's calculate a distance and a slope. How about? And I want you to see how these are just a little bit different. There's something going on here that you need to be aware of. So the points are going to be, how about 1, 3, and 5, 2. Okay? Let's calculate a slope. Actually, let's calculate a distance first. So what's the distance between those 2 points? Square root of, what's my delta x? 4. 4, right? Plus, what's delta y? 1. Okay, yeah, we could call it -1 if we want to, couldn't we? And it really is, but remember what we always said, and this is why we can do this. Because we're squaring it, the outcome is always going to be positive, right? And so it doesn't matter if we square a negative or a positive, and it's a source of potential calculation error when we square a negative, because people oftentimes on a calculator forget to put the parentheses around it, and so it messes up the calculation. And sometimes you can't tell if you messed it up, because it still seems reasonable. Yeah.
What's on your head?
Not important. I had to have a little piece of skin burned off. Better than dying of skin cancer, I guess. So anyway, so look at this here now. If we could have made that negative, the answer would have been the same. We choose whenever, and we can just make a general rule out of this. Whenever we square a negative, just always square the positive, because the answer is the same thing, right? So that's why the delta x sort of evolved into something different for a distance formula, because it's being squared. We don't have to be careful about sign. Always make it positive. But in the slope formula, are the delta y and or the delta x being squared? No, they're not. So therefore, in that situation, the sign is important, because as you well know, a positive slope is very different than a negative slope. They mean different things, right? So when we calculate the slope of this thing, we do have to be careful. So what really is delta y? Sign is important. 2 minus 3, right? Now, and it could be, well, let's assume that we're going to take this as our second point and that is our first point, right? Then we'd have y2 minus y1 is 2 minus 3, right? Which is -1. We have to be consistent. If this is what we're going to call point number 2 and that's point number 1, what is delta x? 4. 5 minus 1 is 4. We could have just as easily flipped those around and called that 2 and that 1. It's fine. What would we have gotten for our delta y then? 1. And our delta x? either way, it's equal to negative 1/4, isn't it? Right? I know I don't mean to insult you by going through that, but I just think that maybe that's something that's worth, I know it's not difficult, and you probably all knew this from the very beginning, but just something that's worth mentioning. Sometimes people get confused with that. Okay, so moving on, parallel lines. What can you tell me about slopes and parallel lines? Yeah, they have to be the same. And that is on our sheet, I can't remember what we called it, but that is the definition of slopes of parallel lines. In a coordinate plane, two lines are parallel to each other if and only if they have the same slope. So what is an if and only if? What do we call that? Biconditional. So we can read that in either direction. Goes both ways, right? So if we know that if two lines are parallel, then the slopes are equal, right? Or if the slopes are equal, then the lines are parallel. It works just as well in both directions. Okay, so dealt with that. Okay, so now you quickly on your notes there, just scratch this out. Tell me real quick, are the lines parallel? How would you check? Right. Maybe you don't even need to write it down. I bet you may not even have to. What's going to be the slope of the top line?
1.
So what minus what over what minus what?
7 minus 2 over 0 plus 6.
Over 0 minus negative, which is plus.
It's
Good.
7 minus 1. No, it's not. I have no idea.
So 5, 6?
Yeah, I'm going home, I'm sorry.
Okay. Now, here, that brings me to another little hint I'll give you. Whenever you're calculating slopes, I would always suggest that you pick the rightmost point as 0.2 and the leftmost point as 0.1. How come? But what does that give us in our fractions then? Think what this is. The slope is rise over run. The run is delta x. What can you tell me about the value of delta x if I always subtract the left x value from the right x value? Okay, it's always going to be positive, isn't it? Yeah, then I'm always subtracting a smaller number from a greater number, right? And so I'll always get a positive number on the bottom, which is also not essential, but preferable when you do math. You're less likely to make a mistake if you always keep the negatives, if they happen, in the top rather than the bottom, right? Does that make sense? So always call the right one 0.2 and the left one 0.1. So there's that slope. How about this one? What minus what? Okay, 1 minus negative 4 over 5 minus negative 2. Is that right? Yeah. Gives us what? 5 sevenths. So are they parallel? No, they're not parallel. Good. Okay, so how about this one? I want you to think, maybe try this. Think about it for a second. Write an equation of the line with the y-intercept of negative 5 and parallel to the line y equals negative 5/7 x plus 9. Sounds hard, but is it? Avery, what do you think? Maybe we don't need to write anything down.
Y equals negative 5/7 x minus 5.
Yeah, exactly. Right, we all know, what do we call this form of a line? Slope intercept, good, where we're given the slope and the intercept are explicitly seen in the equation, right? Just by observation, we know that the slope is negative, or by inspection. We know that the slope is negative 5/7, just by looking at the equation, by inspecting it. So there's our slope, there's our new y-intercept, piece of cake, right? We just get y equals negative 5/7 x minus 5. That's it. Right? No biggie. We're just getting warmed up. Okay, how about that one? Think about that for a second. I want you to think about the process you're going to go through. If I want to come up with the equation of that line, so what are the essential ingredients if we want to have the equation of a line? We need the, what are the two parts of the equation?
Slope and y-intercept.
Say it again.
Slope and y-intercept.
Slope and y-intercept, right? Slope, well, we have one of them. We have the slope. What's the only thing we need? Y-intercept. Okay, so you're used to probably doing this, but I want to illustrate a more important kind of a process in math that we do. Now think about this in terms of an equation and some given information, and this will carry you all the way through calculus, thinking about it this way. So we have an equation of the form y equals mx plus b, right? We just want to identify the parameters m and b. Let me just say a word about that real quick too. That works for any line, doesn't it? Right? All I have to do, I can come up with any conceivable non-vertical line. And why not a vertical line? Because the slope is undefined, isn't it? Right? The slope is infinite. And so we can't use that. Infinity is not a number, so we can't use that equation. But as long as the line is not vertical, I can come up with any of the infinite available lines in the whole universe by just tweaking the dials, the m and the b dials, right? If I adjust the m and I pick a certain value of m, that's going to assign a unique slope, and then a certain value of b assigns a unique y-intercept, and by dialing both those in, I can specify a single line, unlike any other line, right? So the m and the b are what we call parameters. They're not variables, right? The variables are the x and the y. I'll come back to this again and again, and even more so next year, but I want you to kind of get a sense of what I mean by this. A variable is something that's going to change even after I pick the values of m and b, right? So for example, if I pick a value of m, let's say m is 2 and b is 3. So I've got the equation y equals 2x plus 3. Now if I want to graph that equation, we all know what the graph looks like, right? The graph looks like a line with a y-intercept of 3. And remember, whenever we plot a line, we always get an anchor point, and then we find a second point, connect and extend every time. So there's our anchor point, the y-intercept. How are we going to get a second point? Slope triangle, good. We rise 2 and we run 1 because the slope is 2 over 1. There's our second point, and then we just connect and extend. So how many different x and y values are contained on that line? Infinite number. We can't just randomly pick them though, can we? For every x value that we choose, we have to have a calculated y value based on this equation, right? There's an infinite number of them, but if I pick a value of, say, x equals 11, there's only one y value that goes with that. 2 times 11 is 22, plus 3 is 25, right? So we'd have the point 11, 25. Has to be that one y value though, right? Has m or b changed as I calculate different x and y values? No. It's the same, right? So for a given value of the parameters m and b, x and y are still going to vary through an infinite number of values of x to find all the infinite values of y that go with them, right? You see the difference? That's why x and y are variables, because they always vary. M and b are parameters, because once we dial in values, they're set, right? Does that make sense? It's kind of a subtle distinction, but it's important. All right, questions on that? Yes?
So, are you gonna be our teacher next year?
I don't know. I'm not, we don't know. We see how it works. That's the class I usually teach, so probably, but we never know. Okay, so then, back to what we were talking about. So we've got this equation of this line of the form y equals mx plus b. Let's say we aren't given both the values of m and b, but we're given one of them, 2/3 in this case. As long as I know a point, a value of x and y that are on the line, then how many of the 4 players in this equation do I actually have values for? 3, right? I have the values. I know that when x is when x is -5, y is equal to 4, right? I don't know, x can vary and so can y, but I know that when x is -5, y is guaranteed to be 4, right? So I can substitute those values, can't I? And I know that m is always 2/3 for this line. We'll make that a red line, because that's one that never changes. So by plugging all that stuff in, how many unknowns do I have? Only one, right? And so I can always do that in math. If I can manage to find values for all but one of the unknowns, I can always solve for that other unknown. We'll do that a lot. So then, that's our of course, you knew that, that's our strategy, right? So if we want to find B, we'll just plug all that stuff in. Oops. And get what? So y is 4 equals 2/3 times -5 plus b. So what do I do to solve for b? Yeah, just simplify. Find that product, whatever answer I get, just move it to the other side and isolate b, right? So 4 equals, what fraction is that? -10/3, good. Because that's just a -5/1. So what's b equal to then? So, and you got that from just saying 4 plus 10/3, right? How many thirds is 4? 12/3. I could multiply this by 3/3, right? And get 12/3 plus 10/3 is how many thirds? Yeah. 22/3. So what's the equation of our line then?
Y equals 2/3 x plus 22.
Yeah, y equals 2/3 x plus 22/3. Is it starting to make sense why we can plug, why we only keep the values of m and b in our equation? Right, because those are the things that don't change for this line. X and y are the variables, right? Okay. All right, let's see. How about that one? It's a little weird. The line x equals 6. What's that look like? Straight up and down. So if I were to graph this line, it just looks like this, doesn't it? Okay, let's talk about this a little bit. This is fun stuff to talk about. The line x equals 6. Why do you suppose we call it x equals 6? Because, okay, see a hand, but what do you think, Katie?
The slope is undefined.
Okay, the slope is undefined, that's true. So if we start with y equals mx plus b, we know right away that we've got problems because we can't plug in and out. So that scheme is out the window, right? But why x equals 6? That's, well, your answer, I like your answer. It tells us why we can't use that form. But how come we're using the form x equals 6? Don't really think.
Because no matter what y is, x will still be 6.
Yeah, because that's really, all we need to define this line is the knowledge that x is always 6. What could y be then? Anything. If we come up with an equation, and this is also another big deal in math, if I come up with an equation like x equals 6 that defines a line, we all know that lines are two-dimensional. Lines are built up of points that all have x and y coordinates. So what are the math gods telling us here? If all they're saying is x equals 6, if y doesn't even show up in the equation, that implies something important about y. Doesn't matter, right? It doesn't matter what y is. Y could be, pick a value of y, 11, right? So, okay, so y is 11. What's x going to be? 6. Okay, y is -pi. What's x? 6. It doesn't matter, right? If I look at any of the points on this line, the x value is always going to be 6. The y value could be whatever, right? Okay. So then we can make this pretty simple. We don't even really have to do this using some kind of fancy equation to solve this problem. If I want to write the equation of a line that passes through the point 3, -5 and is parallel to the line x equals 6, what do we know about the line if it's parallel to that one? Okay, it's undefined slope, meaning the line is vertical, right? It's a vertical line. And if it's a vertical line, yeah, it's defined by its x value. The x value is the same everywhere. Well, what's that x value have to be? 3. Yeah, right? So we know then that the equation of the line is just going to be x equals 3, right? No big deal. Okay, now that's a little different from, let's compare that to, we're covering lots of good stuff here. Let's compare that to one like this. How about if we want to do, what if we've got the equation, say, y equals 5, and we want to find the line parallel to this one, parallel to y equals 5, through the point -1, -3. Okay, well now this time, what can you tell me about the line y equals 5? Okay, x doesn't matter, you're right, it's horizontal. What's the slope? 0, but 0 is a number, isn't it? 0, infinity is not a number, but 0 is. So this one really does fit the whole scheme of y equals mx plus b, right? What does that become if m equals 0? Well, 0 times anything is 0. So therefore, a horizontal line with a slope of 0 is always defined by its y-intercept. But the same tricks still apply, don't they? If we want to find a line that's parallel to y equals 5, through this point, we know that that line is, what? Horizontal. It's got a slope of 0. So it's, therefore, what does the answer have to be? Yeah, y equals -3, doesn't it? It's got to be defined by its y value this time, right? Make sense? Okay? All right, last one. When are we out of here?
20.
Yeah, when is it? 120. Oh, 120. Oh, yeah, last time. Okay. So slopes of perpendicular lines. What can you tell me about slopes of perpendicular lines? What does it, perpendicular means what? They meet at, good, right angles, 90-degree angles. Okay, what about the slopes of those?
They're reciprocals of each other.
Okay, almost. They're not just reciprocals. Ah, they're opposite reciprocals. Good. Yeah, they're opposite reciprocals. So, if m is a slope, oops, what does that say? Slople. Then the slope of the line, of any line really, doesn't have to be the line, of a line perpendicular to the original line is, that's the notation I like to use, m sub perpendicular. Just means m perpendicular equals -1/m. Just the opposite reciprocal. Okay, so we can use that information. What about something like this then? Write the equation of the line perpendicular to this line. Say it's perpendicular to this line at the point 0,5. So they cross at the point 0,5 and it's perpendicular. Okay, what do we need?
Slope.
Yeah, all we ever need is just a point and a slope, isn't it? If we have a point and a slope, we can always find the equation of the line. So what's the slope going to be? 3. What's it going to be? 3. Yeah, the reciprocal of 1/3 is 3, and then this is negative, so it must be positive. So if that's m, and that's the point, right? Well, actually, we can even take a shortcut here. Normally, we'd have to maybe substitute in the values of x and y and m and solve for b. But what's unique about that point I gave you?
Y-intercept.
That is the y-intercept, isn't it? This is directly telling us that b equals 5. So y equals 3x plus 5. That's our answer. Yep.
Y is the symbol for y-intercept B.
It's a French thing again. I can't remember why, but it's a French word. A lot of it's French.
You think it'd be Latin or something?
Yeah, you would. I agree.
It's the French or the Nazis.
Tyler,
They
another
kinda weird.
silent E on it, just
They kind of were. Okay, so we might as well, we got a little time.